What if the reality we perceive, the three-dimensional world we live in, is merely a fraction of the true reality? Welcome to the fascinating world of dimensions and space-time, a realm that challenges our understanding of the universe and our place in it. Consider a piece of paper. It's flat, two-dimensional with length and width, but it also has a thickness, albeit very small. That thickness, that third dimension, is something we often overlook because it's insignificant in our daily lives. Now imagine if our entire universe is like that piece of paper, a slice of a larger, multidimensional reality. In the heart of this concept, we find a theory that is as mind-boggling as it is revolutionary: the 11-dimensional description of four-dimensional space-time. It's an idea born from the realm of string theory, a theoretical framework that envisions the fundamental particles in the universe as tiny, vibrating strings. To comprehend the concept of 11 dimensions, consider a garden hose. From afar it appears one-dimensional, a simple line. But as you get closer, a second dimension becomes apparent, the circular cross-section of the hose. Now imagine a tiny ant crawling inside that hose. To the ant, the hose is a two-dimensional world. But to us, observing from a higher dimensional perspective, we understand it as a one-dimensional line. This analogy gives a glimpse of how higher dimensions might be hidden from our perception. Now let's summarize the key takeaways about the 11-dimensional description of four-dimensional space-time. First, it provides a possible solution to the conflict between quantum mechanics and general relativity. By incorporating extra dimensions, string theory can potentially reconcile these two pillars of modern physics. Second, it radically redefines our understanding of reality. The universe we perceive might be just a tiny slice of a much larger, multidimensional reality. And finally, it opens up exciting new possibilities for theoretical physics. If these extra dimensions do exist, they could lead to a whole new understanding of the fundamental nature of the universe. Bear in mind, the 11-dimensional description of four-dimensional space-time remains a theoretical concept. It's not yet supported by experimental evidence, but it represents a bold step towards a grand, unified theory, a single framework that can explain all the forces of nature. So, while we continue to perceive the universe in our familiar four dimensions, it's fascinating to imagine what might lie beyond our perception in the hidden dimensions of space-time. It's a journey that takes us to the very edges of our understanding and perhaps towards a new understanding of the universe itself.